So let's continue on. Question 13. Looks like we're doing a very similar question with peaches. So their weights were normally distributed, which tells me I can use that bell-shaped curve. They have a mean weight of 14 ounces, and the standard deviation is zero point 0.4 ounces. Among a sample of 1,000 of those peaches, about how many could you expect to have weights of at least 14 ounces? Well, notice that 14 ounces puts us right smack at the mean. So if 14 is right smack at the mean, that means that 50% has got to be at least 14. So really all we need to do is go 50% of 1,000. So half of 1,000 means that's 500. So 500 peaches should be at least 500 ounces. So that was question 13. Not too difficult there. So let's move into question 14 and see if they make it any more challenging to us. So again, we're still doing peaches. We're still doing normal distribution. We have 16 ounces this time. That's our mean. So these are some big boys, 16 ounce peaches. And then the standard deviation for this is zero point 0.8. So if we draw that out, we're going to have 16 is here. You're going to have 16.8, 17.4, and 18.2. If we go the other direction, I can't subtract very well. 16 minus zero point 0.8, do what, 15.2? Then was that 14.4 minus zero point 0.8, 14.4 and minus zero point 0.8 gives me 13.6. So what we want to know is the number of peaches who have weights between 16.4 and 17.2 ounces. So we're talking about somewhere between here and 17.2. So we're looking for something in this region here. So one thing that I can do is convert the z-scores. So this 16.4 I convert to a z-score, and I could try to find the area in the curve. In that sense, it doesn't fall on my empirical rule. So to find the first z-score, again, we have the 16.4 minus the mean, which is 16, and we divide it by the standard deviation, which I believe we said was zero point 0.8. So divide that by zero point 0.8 was the standard deviation. That'll convert that to a z-score. So 16.4 minus 16, and then divide that by zero point 0.8 gives us 0.5. And that makes sense because we're halfway between 16 and 16.8. So we're at this 0.5. That's our z-score there. And then the other one we have is 17.2. So the other z-score is going to be then z equals this 17.2 minus 16 divided by zero point 0.8. So if we type that in, 17.2 minus 16, divide that by zero point 0.8, it gives us then 0.15. So 17.2, I didn't type in zero point 0.8 there, did I? Because I should be over 1. So try it again. 1.2. Yeah, 17.2 minus 6 was 1.2. Divide that by zero point 0.8. That looks better because that was dividing by 8. So 1.15 sounds better because we're kind of halfway between 16.8 and oh yeah, it looks like I got that 17.2 in the wrong spot. So 17.2 would be, try that again. 17.2 would be like over here. So that would be that data, but if we convert that over, we got zero point 0.5 here and 1.5 here. So what I need to do is find the area of the curve for zero point 0.5 and 1.5. So I'm going to do the 1.5 first because it's the bigger area. And then we're going to subtract the zero point 0.5 from that because that's going to remove that area off of it and just give us this area in between. So I got to remove left of zero point 0.5 here. So I'm going to find the z-score. I'm going to find the area of the curve that's related to the z-score. So if the z-score equals this zero point 0.5, then I'm looking for the area that goes with that. So if I can find my file of my graphics here, let's see. Looks like I lost my little file there. So let me pause it here and see if I can find my graphic again. So I need to find 0.5 to start with. Those are negatives. So come down to the other one. So 0.500 would be here. So 0.6915 would be that one. So if I can get that going on. Let's see here. Can't get out of that thing here. Let's see here. So the area from way over here to 1.5 was 0.6915. So then we want to find the area up to zero point 0.5. I'm sorry, I did the wrong one. So let's try. I did the z-score of zero point 0.5. So zero point 0.5 was the 0.6915. I said I wanted to do the 1.5 first, and I didn't. So let's go back and do zero point 0.5 and 1.5. So let's double check that there. So 0.5, see if I can make that a little bit bigger. Try it again. So zero point 0.5 was 0.6915, but we need 1.5 now. So 1.50 would be 0.9332. So 0.9332. So the area of the curve there was 0.9332. So if we subtract these, that's going to give me the area between 0.5 and 1.5. So where did my calculator go? So let's see here. So 0.9332 minus 0.6915. That gives us 0.21, 0.2417. So around 24% of the peaches are going to be between that, but we want to know the actual number of peaches. So out of 1,000, 24.17 are going to be between there. So 0.2417 times 1,000 would actually give me the number of peaches. So if we multiply this answer by 1,000, that gives us then 241.7. So right around 242 peaches would be in that range out of that. So round to the nearest whole number. So nearest whole number would be 242. So we can do that.